Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access the webinar later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many questions as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 6 Amazon gift cards, each valued at $25. So please stick around. Hopefully you'll be one of our 6 lucky winners. We'll also be doing 3 quick polling questions near the end of today's webinar. So please take a look out for those as well. All right, with that, we'll go ahead and kick off today's webinar, which is Detect, Debug, Deploy with Codefresh and Lightstep. Our speakers today are Austin Parker, who is Principal Developer Advocate at Lightstep, and Guy Salton, who is Solution Architect at Codefresh. Welcome, gentlemen. Thanks for joining me today. Guy, I know you are kicking off the conversation, and I know you got a great webinar on tap, so I'm going to go ahead and put myself on mute and let you get right.
Great, thank you very much for the introduction. So yeah, my name is Guy. I'm a solutions architect in Codefresh, and as Charlene mentioned, this webinar is going to talk about how to easily detect any bugs or performance degradations in your deployment as part of a CI/CD cycle, and then we'll see how to easily detect these and then fix them and redeploy to fix any issues quickly. So yeah, just a bit about myself. I've been a solution architect with Codefresh for almost two years now, helping our customers with demos, workshops, webinars, any technical engagements. And you have my email address there, so feel free to ping me for any questions during the webinar or after. You also have the chat box, as mentioned, that you can use for questions, and we'll try to get to them during the webinar. A bit, then Austin can introduce himself, and then we'll continue.
Yeah, so hi everybody, I'm Austin Parker. I'm Principal Developer Advocate at Lightstep. And yeah, I'll be talking about the role of observability in understanding your systems and how observability can help you sort of detect bugs, and then as part of your CI/CD process more quickly, fix issues with your software and understand its performance. Really excited to show you all this demo today. I think Guy wants to go through the agenda and tell you where you can find the code we'll be working on so you can follow along at home.
Yeah, thanks, Austin. So just to quickly go over the agenda for today's webinar, we'll start with a quick introduction on Codefresh and Lightstep and see what each of these platforms provides and what benefits you can get from using them. Then we'll talk a bit about CI/CD in general, and then Austin will explain about the concept of observability. And then we'll do a live demo where we would inspect some deployment, then fix some bug and redeploy using fully automated CI/CD pipelines. As Austin mentioned, the demo application that we're using is actually public in this GitHub repository, so you can feel free to follow along. Any of you guys who already signed up to a free account with Codefresh and Lightstep and have a Kubernetes cluster in hand, you can really just try to follow along together with us during the webinar today. But of course, this webinar is recorded. You have the link to the application source code, so you can, of course, do that afterwards. So a bit about Codefresh. Codefresh is the first container native CI and CD platform for microservices designed and built for Kubernetes. And so if you think about more traditional CI platforms like Jenkins, for example, where you have to maintain, slaves as build nodes, and then pre-install all the tools that you want to use on these nodes and make sure that you update them and maintain them. With Codefresh, every step in the pipeline runs in a Docker container. So this really eases the management and maintenance of your pipelines. You'll see also that in terms of UI and UX, that the platform is very friendly and easy to use. Yeah, that's a bit about Codefresh, as you'll see everything during the demo.
Yeah, and so when you have, continuous integration, continuous delivery, your system is changing a lot. And the only way that you can really be confident in sort of the changes you're making is through observability. Lightstep is an observability platform that allows you to analyze 100% of the requests that move through your system. We can automatically detect regressions and deployments. We can perform aggregate analysis across, millions or billions of requests per second to give you real-time root cause analysis, alerting, and it's all built on open source technologies like open telemetry, so there's no vendor lock-in. A little bit more about observability here, excuse me, because this might be, you've probably heard of CI/CD, you probably even heard about monitoring, but observability might be a new term. So just to introduce it, observability is kind of, it's not actually, a piece of software, right? You can't necessarily buy something that gives you observability. There are tools that can help you with it, but primarily observability is about how do you understand your system? How do you understand what your system is doing? And I pretty often get questions like, well, what's the difference between this and APM, or what's the difference between this and monitoring? Fundamentally, I believe that monitoring is very disconnected from the development lifecycle, right? Like monitoring is about saying, well, hey, here's some key indicators we care about, and we're just going, if it like RAM or CPU usage or requests per second or error rate, and so if one of those numbers goes out of line, you throw an alert, and then some dev is getting a ticket to say like, well, why did the error rate go up, right? And that's monitoring. Observability is about having the ability to look at your entire system and really understand what correlated with that error rate going up, right? Or why did memory increase? It's about having all of this information available and then being able to ask arbitrary questions about your system. And that's extremely powerful when you combine that with CI/CD, because it really saves you time. And if there's anything we could use more of these days, it's time, I think. So CI/CD, as I said, speeds up your development velocity a lot, but that velocity has these trade-offs. And one pretty common sort of pattern that I think we get into as developers or as DevOps people is something changed, and a new feature was released, and that had an impact on performance. But why did it have an impact on performance, right? A lot of times these systems are very disconnected from each other, or the person or people that are pushing changes maybe aren't the people that are responsible for ensuring uptime or ensuring reliability. So you need this combination of tools. You need ways for the code to change quickly, but you also need observability tools to understand what is happening as a result of those changes. So there's sort of a prerequisite for this, right? And it's instrumentation. Instrumentation is a way that you modify your source code and you modify your service to emit telemetry data. Now, one pretty common concern or complaint or something you hear a lot is like, oh, I can't get developers to instrument their code. People don't want be locked into some proprietary tool, some proprietary APM tool or whatever in order to understand performance. Well, this is where things like OpenTelemetry come in. So OpenTelemetry is a vendor-neutral project managed out of the Cloud Native Computing Foundation, CNCF, and it is a vendor-neutral API and SDK for generating telemetry. Now, one really cool thing it offers is this idea of automatic instrumentation. So if you're familiar with agents, agent-based instrumentation approaches, OpenTelemetry, the biggest idea here is that a lot of companies, a lot of vendors will provide these to you, but they're fairly undifferentiated, right? They're fairly similar in what they do. If you've got, Express or Spring or some popular framework, they will find that code, they will add in some hooks around it, and they will, instrument that so that you can see the performance. But there doesn't need to be like 10 different options, right? You shouldn't have to juggle multiple different types of agents in order to inspect your services. You shouldn't have to, maybe your company acquires another company or you have a new product you're integrating and then they used vendor X and you use vendor Y. And so now you have this big integration problem. Or you have an issue where it's like, oh, I can't, I have to go between 5 or 6 different tools in order to see one request as it kind of moves through these heterogeneous systems. OpenTelemetry is seeking to kind of do away with that by providing a single, well-documented, highly supported, set of auto instrumentation tools for all the languages that it supports. So today I want to kind of show you something, a sort of a real world scenario here, right? Let's assume that we have an application and we've already, this is an application that's running in Kubernetes. We've already got CI/CD set up. We're using Helm to deploy it, and someone pushes a new feature. So let's switch over here and take a look at our app. So the first place I want to start out is kind of in Codefresh, actually, and this is just to show the build and how this application is being pushed. So we have a fairly straightforward pipeline here. And if I can jump into it. Yeah, did the same thing twice. But either way, we're cloning our code from GitHub. We're building these 2 Docker images, one for a client, one for a server, and then pushing those to Docker Hub. And then we're deploying a Helm chart.
Yeah. By the way, Austin, can you click on the Docker build step, one of these ones? Just to note that if you can scroll a bit up on the logs, you'll see that Codefresh has a built-in step for building Docker images, and it has built-in Docker image caching as well as distributed layer caching. So you'll see there in the logs, as this is not the first time Austin ran this build, is that it automatically reuses, you see it says using cache, reusing any existing layers of the image from the cache and then only builds the new layers. So there's a lot of like caching optimizations that can really reduce the time of your builds, and it's all built in, like you don't really have to do anything about that.
Yeah, and I can actually look at how this is all configured. We're kind of doing a code first or infrastructure as code process here. So my actual build configuration is all contained within a YAML file. You can see this if you're following along in the GitHub repo, you can actually see this file. And there's some stuff in here that's kind of like some of this metadata we're setting. These are sort of just like demonstration images or values. In the real world, you would probably want to put, your own tags here. And we'll look a little later at what these actually mean or how you can see these in the Codefresh UI. But we have a bunch of values kind of configured here. And what this lets us do is this lets us use Codefresh as sort of a one-stop shop for looking at our environments, looking at our application. So here, for example, is the environment that my application's been deployed to. I can see that it's deployed. I can actually really quickly jump to that recent build. And if I click on this, I see my application. So this is, a pretty simple to-do app. So, but there's a problem, and it's right here that I'm supposed to be getting a cat fact every time I look at my to-dos, because I, along with the rest of the internet, love cats. And I want to look at cat facts when I'm looking at my to-do list. So I see that some cats are throwing exceptions, which isn't really what we want. So let's add a to-do here and get that sent in. So we know that our application is broken somehow, right? We know that some cats are throwing exceptions. Let's switch over and look at the actual code. So here's my application, just to kind of walk you through it real quick. Again, here's my Codefresh YAML. I have 3 directories I really care about. I have my Helm chart, which is responsible for deploying the application to Kubernetes. I have the server code and the client code. So let's look for that exception. It's right over here. So I can see that I'm getting an exception somewhere in this. But what if I, didn't have access to this entire application? What if I was what if I didn't even what if I wasn't able to actually like jump to this one exception? I might say, well, okay, it was a little slow kind of doing some things there. There's some exceptions happening. I don't have the data I really need to understand what's going on. Maybe I could go pull the logs and look at that. But if this was, you can imagine a more complicated application that's distributed across, many, many, many containers. What if it's only one of these containers that's having a problem, right? Looking at logs is going to be time consuming to say the least. So what I'm going to do is I'm going to use OpenTelemetry and Lightstep to quickly understand what's going on in my code. This is all documented in the README if you want to follow along, but basically we're going to start by adding the OpenTelemetry instrumentation for Java to
Austin, if I
our
can just
Docker
stop you
file
there
here.
For a second. Yeah, we got a question on our question box, which was what the Helm chart. So maybe just a few words about Helm. Helm is a package manager for Kubernetes. So if you are like migrating to Kubernetes, looking at Kubernetes, you should definitely check out Helm. It's an open source project that lets you treat multiple Kubernetes manifest like a deployment YAML, ingress YAML, service YAML, all as like a single entity. And it also has built-in capabilities for version control over versions of your release. So makes it very easy to roll back to previous versions, and we'll see some of these capabilities in today's webinar. So yeah, just check out Helm project. It's very, very useful for deploying applications to Kubernetes.
Yeah. So while we were talking about that, what I've done is I've added a couple things to my Docker file here from my server. And I'm downloading 2 jars. This is the OpenTelemetry Java instrumentation. And what this is really 2 components. It's a one that kind of instruments the application for me, and then another one that lets me export data. So I add both of those to my Docker file, and then during the build, it will go and download these. And then I'm setting an environment variable in the container, which is the name of the service, which I'm going to call to-do server. This could be you can override this, but I'm setting a default just because it needs one to work. And then in my entry point down here, I'm adding a couple of flags for the JVM. So I'm passing a Java agent flag, and I'm telling it to use otel.jar, which we've set up right here. And then I'm giving it sort of a default endpoint for a collector. And I'm also telling it what exporter jar to use. Now, if I run this, what will happen is, without me having to edit any of the code in my Java application, it will automatically go through, and at application startup, it will look and look for things that can instrument, right? So this is a Spring application. Um, we're using Spring Boot, and Spring Boot is responsible for really kind of setting up all of the servlet containers and all the other, making it an HTTP service. It's responsible for kind of talking to MySQL and setting up a data repository for our, again, pretty simple to-dos. So without me having to change any of this stuff, just by adding OpenTelemetry into the Docker file, I'm going to get sort of traces for every request that comes in. But I need to send those somewhere. So the next thing we need to do is we need to add a collector. And the collector is going to be, we're going to skip a step, actually. We're going to go to the collector first. So the collector is, there's a lot of YAML I'm about to throw in here, and I'm not going to explain it all just because there's a lot of it. But what the collector is, it's a process that can collect and aggregate trace and metric data from multiple other processes and then export it to a backend service for later analysis. So in this case, the thing we can actually care about is this config map, which has a collector config, and this is telling it to do a few different things. One, it's saying, here's a receiver for OpenTelemetry protocol. So this is the wire format for telemetry data from OpenTelemetry. It's registering a couple of extensions and processors, and this is stuff like, hey, batch these as data comes in, batch it to go out. Make it so you can like retry to send stuff. We also add in a health check, and then Z pages, which is for diagnostic information about the collector itself. And then we're setting up 3 exporters. So our Prometheus exporter is so that we can export metrics about the collector or about our applications to Prometheus. And that will be listening on port 8889. We also have a logging exporter. So this is just going to put information in standard out. And then we're setting up a Lightstep exporter in order to send data to Lightstep. We register all those in the service section. And then that's pretty much it. There's the rest of this is just exposing ports, telling the collector where to live and where to be available from, and other various Kubernetes things that needs to happen. So there's one other part of this that we might care about, right? We've got our server instrumented, we've got a collector for that data, but what about the front end? Now, this is a Vue.js single page application, and the nice thing about that is everything kind of runs in the browser, right? Like I'm not if I look at the Docker file here, actually, it's pretty lightweight. We're just taking the compiled version of our app and then we're putting it behind Nginx and then throwing in a container and saying, hey, expose port 80.
Yeah, by the way,
So,
notice that, we're using a multi-stage Docker file.
yeah.
So yeah, in production, you don't want to have all the build tools and unnecessary tools. You only want like the most like lightweight container that would be both secure and lightweight, so it would be fast to deploy and also more secure.
Yeah. So what I'm going to need to do is I also need to add OpenTelemetry to this client application. Thankfully, there's auto instrumentation for Java, but there's also automatic instrumentation for JavaScript, even in JavaScript in the browser. So if I go and I look back a section here, there's 2 parts to adding OpenTelemetry to our client. The first is going to be adding some dependencies to our package.json. So let's pull these over. and add them to the dependency section here. The second thing I'm going to need to do is I'm going to need to create a new file. I'm going to call this tracer.js. And we're going to take this section of code and paste it in there. And I'll explain what it does. So what tracer.js is doing is it is importing all of our OpenTelemetry libraries and configuring them. This is some of the stuff that, kind of behind the scenes on that Java side is being done for you. With the nature of JavaScript, like this was kind of how they decided to do automatic instrumentation, since, well, it's usually a little bit easier to add files, I guess, to JS. But we don't actually have to touch our existing code really at all here. We're creating a exporter to the collector, and then we're creating this web tracer provider and adding these plugins to it. One for document load, one for user interaction, and one for XML HTTP request. So what these will do, when I take this file and I import it, which I will do over here in main, as you can see, I've actually already got it done. If this tracer module is the first thing imported into the application bundle, then it will look and automatically hook into XML HTTP requests. It'll hook into sort of DOM loading and all that other good stuff, and automatically create telemetry for me based off of it. So I don't actually have to go in, I don't have to go into this API component, this API module, and add in instrumentation code here. I just get it for free by configuring it in my tracer.js. So with that done, I'm technically ready. I'm technically ready to go. But there is one other thing that we can do that is maybe interesting. Because, it's nice to have sort of that automatic instrumentation, but there's some stuff that maybe I would still, at the end of the day, we're all humans, right? We're all people trying to understand our software, and there's only so much that, this sort of automatic instrumentation, these agents can do for you. So if I look at this, if I go back to where we started, and I go back to kind of this exception, I see that this is able to throw some exceptions, and I'm not doing, best practices here. I'm not actually getting that exception out in a way that I can easily understand it. So is there a way that OpenTelemetry can make this a little easier for me? And thankfully, the answer is yes. So if I, excuse me, gosh, it's dry here today. So what I'm going to do is I'm going to import something from OpenTelemetry auto instrumentation, which is this annotation called withspan. Now I also need to go into Gradle, and I need to add a dependency. So we're going to grab this automatic annotation library as well. And what this lets us do, this gives us access to the withspan annotation. And what that does is whenever the automatic instrumentation is going through and it's looking for things to instrument, it's looking for code and libraries that it can hook into, it's going to see this annotation here, and it's going to say, okay, I also want to create a new span around this work, right? Because I know as a person that's writing this code, this is probably where the problem is. Well, technically, I explicitly know where the problem is because I'm the one that wrote the bug. But I can tell, like, okay, this is most likely something interesting is happening here, and I want to specifically see this one part. So with all of that done, we would go in, we would add a commit for adding OpenTelemetry, commit, and then I'm actually not going to push this one because I don't want to push that to the base copy, but let's pretend we did. So, and then let's go back over to our browser. Now, while I'm doing this, if anyone has any questions about the specifics of what we're doing, feel free to sort of ask them in real time. We can stop and try to answer them. If you have any more general questions, we will leave some time at the end here in about 15 minutes that you can ask them. So let's pretend that I push all that code, my application's running, great. I want to see what's going on. So I'm going to switch over to Lightstep. Now, Lightstep, as I said before, this is a tool for observability. This is a tool for understanding what's going on in your application. So what I'm seeing is quite a bit of data, actually. I can see, here's from the client, here's the P50 latency, here's errors, here's operation rate. Basically, here's all the key operations of our client-side app. Here's where it's going and getting to-dos. Here's where it's going and getting facts from the backend server. I can also see from the service perspective, what are the key operations here? And there's a lot of stuff. I can, this repository, getting repository, this is a sort of Spring one. Here's an options request. But then I can see some other things here too. This is a SQL statement, right? I can see actual, SQL queries and operations being done by Spring to my backend database, which is really cool. So that helps me kind of understand, at a high level, but let's drill down and actually try to find our specific problem. So this is the Explorer, and this is where I can really start to dig into my data. So I know that my problem is over in that to-do server, and we actually pre-populate, some key operations here. So I know that /fact is the endpoint that is having the problem. So when I filter down, I can see we have 2 here. So let's click on this one and see what's going on. So what I've got is a trace of the entire request from beginning to end. This is from the view application up here. You can see to-do client XML HTTP request. This is where it was trying to go fetch /fact on the server. And then I can see here's where we're going from kind of one method to the other. This is where it's being handled, and then it's going into the controller. And then this is the method, the getCatFact method that I had put that annotation on that we just saw. And over here, I can see that we have these tags that show, oh, here's my stack trace, right? I can see can't construct an instance, cannot deserialize from object value. And then here's kind of this full stack trace. And I can see the specific type of the error. Now I note that OpenTelemetry is still in beta, so some of this is showing up maybe in a place you wouldn't expect, like this would presumably be a log rather than a tag, but again, beta software. I can also view kind of detailed information about the specific operation, so I can see like, well, how long did, for the entire sort of request, what was the contribution of this one particular span to that overall latency? Looks like 6.29 milliseconds, which wasn't a ton. So with that said, it's like, oh, okay. Now I know what my problem is. If I switch back over to here, I can actually go back into catfacts, and the problem is that it's missing a constructor app. So we'll add catfact super. We'll do another. Whoop. save that, and then we will stage and push. Push on the one you can't see. And now let's jump back into Codefresh. So what I've done is I just went and pushed the fix, and you can see in my build here that we are cloning, we are building, and then we will start deploying here in a moment.
Yeah, so we had a Git trigger attached to the pipeline, and then once Austin made the change in the repo, this automatically triggered the pipeline, and then you see that it's running. One cool thing that you can note is, Austin, if you click on the initializing process box there, you'll see that what we do to share data between steps is, because every step runs a container, we provision a volume, a persistent volume for each pipeline, and we then mount this volume to each container that runs as part of the pipeline. So you see that as this is not the first time the build is running, it says that it's actually reusing a volume. So the first time the pipeline ran, it downloaded all necessary dependencies and performed all kinds of steps like that, like loading the repo and all that stuff. And then the next time the pipeline runs, all of the same volume is used again. So you don't really need to download the dependencies again if you already did that in the previous execution. So the second build and onwards will just run much faster, and it will also be able to utilize all these caching optimizations that I mentioned earlier.
Yeah, cool. We can also, so while that's deploying, let's take a second to look at some more stuff in Codefresh. So I mentioned earlier, Codefresh is able to kind of keep track of these images for me, and so I can actually see here, here's, that to-do server that I just built. So you can see here's those annotations that we had on there. This you can actually link back to other systems, other integrations you might have, like with Jira or whatever. I can look at, the Git SHA that this came from. I can
Yeah,
get
and this is
the exact
actually
image.
pretty powerful, especially the code section, I think, because as you have both CI and CD capabilities in the same platform, you can trace back the changes from this image that is already deployed to your Kubernetes cluster all the way back to the GitHub repo to see the exact commit and change that the developer made, Austin in this case, that eventually built and deployed this image. So if you ever wondered for Kubernetes deployment, especially in the microservices world where you probably deploy multiple times a day, for this specific deployment, does it include my latest commit or it doesn't? So here you just have this traceability built in. And just one note on the annotations. If you notice that Austin showed that in the YAML at the beginning, you can just add a condition. So let's say you run your unit test as part of your Docker file. So once you run the Docker build test, the Docker build step, this actually runs your unit test, and then you can just add like a condition saying, if this build step passed successfully, then I know that the unit test also passed. So I can just add like a quality annotation to my image and add any metadata as annotations. And this way I can then identify which images has passed some tests or security scans, for example, and which hasn't. And I can nicely see this in a visual representation in the platform as well.
Yeah. So let's actually switch over here and look at our environment again. So you see we have our new build for fix cat fact. Now, hopefully, I believe this is it. Yeah, so we can see that, we can actually look at the Helm interface here. We can see that our build was deployed, and we can jump in and actually get a lot of information about what is all exactly in here. So, like I said earlier, we're using MySQL, and you can actually see, here's our MySQL image. We can see the health of these. Here's my Prometheus containers that are also being deployed with it. And I can see my to-do client, my to-do server down here. I can also look at the history. One thing that we're not going to really show off in this demo, but if you want to find our last one where we showed this off, there's a really powerful rollback feature in Codefresh where you can, like, I could click this here. Like, let's say that, maybe I deployed instrumentation and I had a bug, or maybe the instrumentation didn't work quite right, and I want to really quickly go back to what I just had. I can just click this rollback and go back to the last successful release, or the last, or whatever release I want to roll back to, without having to kind of do a whole bunch of,
And you can even click on just anywhere in one of these version boxes, Austin, right? And it will show you, yeah, this is the current version. But if you click on any previous version, it will show you which files have changed. Like in this case, none of these files have changed, but it will show you what was the actual change. And then you can easily roll back, to any specific version. And this, by the way, relates to this initial question we got from the audience about what is a Helm chart. So this capability of Codefresh is actually built on the built-in capability of Helm for built-in rollback and version control. So that's why, we usually recommend using Helm for Kubernetes deployments.
Yeah, it's really great. So it's been a few minutes now. So let's check our application out. Let's see if we have cat facts. So we're loading. And look at that, we have a cat fact. Cat fanciers bred and exhibited mouse in Europe until World War II, and attention towards the cat waned and it nearly went extinct. I don't know what that is. After humans, the mountain lions have the largest range of any mammal in the Western Hemisphere. Cool. So I think we fixed our application. Let's clear that out. And we have a few minutes left here, so let's actually jump back into Lightstep and kind of show you the difference and show you, some of the other stuff that you can do with observability, because, yay, we fixed the bug, right? Great. That's now everyone that comes to use our cat fact app will be able to see their cat facts in peace. But there's some other interesting things here that, maybe I don't want to know today, but I want to know tomorrow, right? Or I might have questions about later. So just looking at that fact endpoint, we can actually see some interesting behavior in the durations of our, how long is it taking? Because if you recall, that first time I went and hit that endpoint, like the first time after the deployment, like it took a minute. It took like noticeable amount of time for this fact to appear. So I can see like, well, here's a 1.72 seconds. Why did it take that long? Well, it looks like the majority of that time was actually being spent in this get to my remote server. So that looks like almost 50% of the latency on that cold start was, actually going and getting something from my remote endpoint. And then on subsequent ones, it's much faster. So maybe I would, maybe someone's looking and it's like, hey, why is it so slow every now and then? And this would actually let me see that it's not actually something in my code at all. Just looking at the behavior, it seems that this external API, whenever it cold starts, has a longer, wake up time. So now I've been able to, now I can kind of say, it's like, oh, well, this is the actual problem. And then there's so much more that you can do with this data. Like I said, we only really added one kind of custom thing, but I want to just explore some of what you're getting for free here. If I go and I look at the client and run a query, so I can see all sorts of these operations here. So I can, let's maybe filter to the document load. So I can see each time I'm loading, I can look, how long did it take for kind of each of the components to load, right? I needed to fetch the document. Here's my CSS bundle, my JavaScript, what's taking the longest amount of time, right? And then I can actually even see, like, of this individual operation, how long did it take for certain things to happen? So, looks like we had 2 milliseconds between the connection getting set up and then request. So again, I'm getting a lot of like really detailed timing information about. I went from fetching my content, the DOM became interactive 73 milliseconds later. And this, again, is something that I was able to configure with really one line of code. Let's look at the server, because maybe I'm a backend dev and I want to know, like, hey, well, what's the performance of a certain repository, right, or a certain SQL query? So here's that find all operation. This is going to only run once when I start up the app. But I can actually see here, this is just the SQL query itself. This is like that database statement. So if I wanted to, you can sort of see, in a world where I've got a lot of different queries, or a lot of, certainly more operations, more stuff happening than this in this small demo, I'm able to look at one specific query and then see how long is that taking over time. Is the performance of that query getting better or worse? How does that change as the parameters are different? There's quite a bit of interesting performance data I can kind of tease out here. And then I can even say, like, well, hey, just what's slow, right? And see, here's my top 5-10%, let's say, of slow requests. And a lot of this is probably like, it's a cold, the container was starting cold, so there's some additional overhead in Spring doing stuff. Like if I come back and kind of refresh this a bunch. Cats dislike citrus scents. And then come back into Lightstep. Give it a second. And then let's group by HTTP method. And so now I can, now I'd be able to look and say, like, oh, okay, well, for GET, here's my average latency for all GET requests. And then I can look at the specific ones, kind of drill down in. I can go up here and look at, if I had more data, I can look at what's correlated highly with these requests with a higher tail latency. Yeah, a little bit more. And I could see, like, maybe it's this one particular user agent, right? I mean, it's all going to be my user agent, but here's a good one. Application filter chain. So again, I can really dive into, see what my individual components are doing, see what is contributing to kind of performance issues in my app, and really just kind of explore and understand what's going on. And that, I think, is, again, kind of the key of observability, right? It's having all this information available to you in order to understand what's going on with your service, understand what's going on in your application, and then be able to detect things that are happening, find them, fix them, and then using tools like Codefresh, quickly and easily deploy those changes. So yeah, Guy,
so
if you...
thank you, very much, Austin, for the demo. So as we've seen, Codefresh can really make it easier for you to create those pipelines for containerized applications and deploy your applications to Kubernetes. And We have built-in steps for these deployments, so you don't really need to worry about starting like to create some bash scripts or any custom scripts to handle the deployments or any other steps. Like we have all of these built-in steps that you can use. And as Austin showed, it's very important as part of CI/CD, especially to not only be able to respond fast and deploy fast, but also to identify easily when there are any bugs or performance degradations, so you know that your users are getting like a bad version of the application, so you be able to easily fix and redeploy. Yeah, we have some questions. Austin, one question here is how is this different from Zipkin?
Good question. Thank you. So it's built on, so Lightstep as a platform also can integrate metric data like host metrics and infrastructure metrics to give you sort of a unified picture of observability about your services. But fundamentally, Lightstep is built on distributed tracing, which is what Zipkin is. Zipkin is a distributed trace analyzer. We actually can accept data from Zipkin if you want to see the difference. The functions that I was showing, like being able to filter and group by tags, being able to see what's correlated between, certain operations, and saying like, I didn't really show it a ton in this demo, but you can imagine, if I had, 1,000 requests per second or something, and they were all from different sort of hosts or whatever, then I could use that correlations feature to say like, okay, well, for my kind of long tail latency, for my slowest 5% of requests, what do they have in common, right? Are they all from a particular region? Are they all hitting one container or another? And sort of that automated insights into what's going on through heuristics, like that's what Lightstep, I think, really differentiates itself with compared to something like Zipkin. Zipkin's fine for sort of analyzing individual traces and doing a little bit of group analysis on them, but we really shine on that sort of, taking in 100% of your trace data and then analyzing it in real time and giving you insights for, if you're trying to do firefighting or something like that.
All right, guys, it's about 8 minutes to the top of the hour. I think we have time for one more question that I see here in the queue. Is it possible to introduce tracing without polluting code with tracing related statements? It's not easy to convince to adopt due to presence of non-core logic. So is there another way, and what are the best practices?
Yeah, also a good question. I mean, I mean, yes. Like, I feel like the demo was trying to be extremely not adding trace. Like you don't have to add. I didn't have to add that annotation, right? But if you look at the backend from the Java side, at least, like I added like 2 lines of actual code, one import statement, and then one annotation on a method. So for things like Java or C#, like it's very easy to add this stuff in and have it be mostly invisible and not have to add in anything else. On the JavaScript side, sort of the same deal. Like, yes, there was tracing code, but it wasn't really polluting anything else. It depends on the language. Like if you're using, let's say you're using Go, okay, you're gonna have to have tracing code. You're gonna have to add in tracing code in Go. Even with some of the automatic instrumentation options and the library wrappers that exist in Go, like you're still going to have to change, you're going to have to pass a different argument or wrap your HTTP handler in a tracing wrapper in order to get traces. Like it's just not, as a language, it's not really built in the same way that like C# or Java is, and you can't do all the fun bytecode manipulation tricks. But in managed things like Java or C#, in dynamic languages like Python, it's super easy to add in very lightweight auto instrumentation that kind of rewrites, prototypes, or adds instrumentation automatically at runtime or at build time in order to avoid this complaint about quote unquote polluting the code base tracing code. That said, like, do people complain about polluting the code base with log statements? Like, I sort of challenge the fundamental assumption here that tracing code is somehow like less worthwhile, right? Observability, like telemetry isn't a nice to have, it's a requirement. If you want to know what your application is doing, you need to add code to it. And developers at some point are going to have to, like, we need to combat the assumption that, like, oh, this is some extra thing that is heavy and opaque or oblique or whatever. Like, you have to be able to understand what your code is doing, and you have to be able to add in statements in the correct places to get that information. So I'd be happy to talk more about this with whoever asked the question offline. My email is right there, or you can find me on Twitter at Austin L. Parker.